assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Hello everyone, this is and today we're working on 6 from chapter 22. We're going to be drawing the structures of all the geometric isomers of this complex ion, as well as drawing the mirror image of any molecule. Just a refresher, a geometric isomer is the isomer of a compound with ligands having different spatial arrangements about the metal ion. There are special types of geometric isomers such as and facmer. So for simplicity's sake, let's write out a generalized formula where metal ligand A is 2, B 2, C 2, where A is equal to H2O, B is equal to NH3, and C is equal to Cl2. Or rather, that's the chloride ion, which there are 2 of them. And because there are 2 of each, the ligands can be either cis with one another or with one another. So for the different isomers, we have, or for the different possible combinations, we can have all trans, meaning H2O is up at the pole, opposite of one another. Cl is pointed to the back, other Cl is pointed out in front. And then along the other axis, ammonia is coming out at us while having the other running along the other, or along the back. And in this case, the all trans is superimposable onto its mirror image, meaning does have an optical isomer. Next up, we can have H2O trans, or for simplicity's sake, we'll go A trans, B, and C cis. And if you ever forget what I'm talking about when I say A, B, or C, got a little key up here. All right, so let's draw it. So we got metal ion, water at the poles, trans with one another. And now both the chloride ion, or chlorine, and ammonia will be cis with one another, or with their respective pairs. So we have NH3 over here now, and NH3 going back. This is another case where we can super image. All right, so next up, we have the case where B is trans, A and C are cis. And in this case, we have our metal ion, water up here, and then you'll have to use your bit of your imagination to visualize this in 3D space. But trust me when I say that water is cis in this configuration. And down here, chloride coming out over here. It's chloride, cis, cis. Then ammonia is trans. And if you're wondering, there's no difference between my shaded and my unshaded wedges. I'm honestly more of a fan of using the unshaded ones. For school, I always had to use the shaded wedges. Our next isomer is the case where C is trans and A and B are cis. And so what this looks like is we have metal ion in the middle. Up at the top, got our water. The bottom pole, ammonia. And in this case, A and B are cis, meaning water and ammonia are cis. So we're going to throw out our ammonia here. Our water come out back here, cis with one another. And then the chlorine is trans, so it exists on opposite sides of the metal. Once again, this is superimposable. Last case is where A, B, C are all cis. And in this case, we have H2O is cis with H2O. NH3 is cis with NH3. And chloride is cis with itself. Now, in this case, we do have an optical isomer. If we throw out our area image, poles stay the same. The chlorine going back, chlorine coming out at you. Water going back. And the ammonia coming out at you. In this case, we have enantiomers because these are not superimposable themselves. So I hope this video was helpful. See you in the next one.